In a world filled with famine and plague, a hero searches for the solution to save humankind. One day, while walking through a forest, she falls into a hole. But as she looks for the entrance to the hole, her attention was quickly diverted. Inside was a scientist surrounded by computers and beakers. The hero walked up to her, looking around. "What is all of this?" "Moth," the scientist said. "Bless you?" "No, it's a moth, a metal organic framework. Come with me, I'll show you." The scientist gestured to the tools beside her, putting together these rods which looked like twigs and these spheres which looked like metals. These twigs are organic material, and the spheres stand for metal. The different compounds together create different kinds of moths. So how is this related to chemistry? You didn't mix any compounds together, really. Well, this is reticular chemistry, coined by Omar. Here we design and engineer structures, not necessarily molecules, while that's still related. So, how is this room related to moths? Well, the outside of the room is a lot smaller than the inside is, which is kind of similar to moths. A really small amount of moths, or a spoon for instance, can hold up to the area of a football field. Take this cube for instance. See how many faces there are? That is how much gas just one cube is able to hold. And these different shapes can all have different applications. And when you add acidic and basic ligands to it, that can trigger different responses. Or, say, changing size. This has different applications, like changing the capture and release mechanism of the moths. For example, imagine the cage getting bigger and allowing a bigger bird to come through. Or it can increase the amount of time that the moth is able to hold a molecule, or the stability of it, which is how Omar was able to create such successful solutions using moths. They have very high lifetimes. The hero and the scientist emerged from the cave and went on to teach others about photosynthetic energy and medicinal systems. Even in the story, in real life, moths can be used from anywhere from environmental issues to medicine. For example, drug delivery and chemotherapy, where it's able to slow the amount of time that a drug is delivered over time, decreasing patient time in hospitals.